Dear students, in this video I am going to explain about lesson number 5, coordination chemistry, topic number 5, crystal field stabilization energy. In my previous video I have explained about the distribution of d electrons in octahedral complex. See here, this is the diagram. This is the topic which we discussed in the previous video, where I introduced the 5 d orbitals in free ionic state, and those 5 d orbitals with degenerate state, its energy got increased, and later the 5 d orbital gets split up into two set of orbital. One is T2g orbital and another one is EG orbital. This is called as crystal field splitting. Now there is some energy gap between the EG orbital and the barycenter level and the T2g orbital and the barycenter level. சரிங்களா, இந்த barycenterன்னு சொல்லக்கூடிய இந்த ஆவரேஜ் எனர்ஜிக்கும் EGக்கும் நடுவில் எனர்ஜி கேப் இருக்கு. barycenterன்னு சொல்லக்கூடிய இந்த ஆவரேஜ் எனர்ஜிக்கும் T2Gக்கு நடுவில் எனர்ஜி கேப் இருக்கு. That energy gap is measured by the crystal field stabilization energy. The actual distribution of electron can be ascertained by calculating crystal field stabilization energy. What is the definition for crystal field stabilization energy? The crystal field stabilization energy is defined as the energy difference of electronic configuration in the Ligand field, that is ELF, and isotropic field or barycenter field, that is EISO. சரிங்களா, இப்போ see here once again in this diagram, where are the Ligand field? Here this is the Ligand field, and here this is the Ligand field. This is called as the isotropic field or barycenter. So the energy difference between the Ligand field and barycenter. The energy difference between Ligand field and barycenter gives the crystal field stabilization energy. What is the formula to calculate crystal field stabilization energy? Delta E naught, E of O, which is equal to energy of Ligand field minus energy of isotropic field. This is expanded as N T2G into minus 4 plus N EG into 0.6 into delta O plus NP into P minus of N dash P into P. Once again, NT2G means number of electrons in T2G orbital. சரிங்களா, number of electrons in T2G orbital. NEG represents number of electrons in EG orbital. NP represents number of electron pair. Electron வேற electron pair வேற. இங்க வந்து just electrons எத்தனை இருக்குங்கிறத மட்டும் நம்ம calculate பண்ணுவோம். Here electron pairs, paired electron இருக்கும். சரிங்களா, so number of electron pairs in the Ligand field. NP dash is nothing but number of electron pairs in the isotropic field or barycenter. Now I am going to calculate crystal field stabilization energy for two different complexes. One is hexa aqua iron 3 complex, and another one is hexa cyanido iron 3 complex. For these two complex, I am going to calculate the crystal field stabilization energy. Once again, I have wrote the crystal field stabilization energy formula as it is. First, I have taken the complex hexa aqua iron 3 complex. I am going to calculate the crystal field stabilization energy by assuming it as a high spin complex and low spin complex. ரெண்டு complex assume பண்ணி ரெண்டு விதமா நான் calculation போடுறேன். First one, outer electronic configuration for iron. Iron atomic number 26. So the outer electronic configuration is 3d6 4s2. Here iron is in +3 oxidation state. So Fe3 plus will become as 3d5 4s0. 3d5 4s0. So இப்போ 3d5 அப்படின்னா நமக்கு இந்த மாதிரி இருக்குமா? So see here, there is no unpaired electron. அப்போ unpaired electron இல்லை அப்படின்னா இங்க என்ன வரும் நமக்கு? NP dash என்ன பார்க்குறோம்? Number of electron pairs in isotropic field. barycenterல பார்த்தீங்க அப்படின்னா barycenterங்கிறது எங்க இருக்கா? This is the barycenter. Barycenter, we don't have any unpaired electrons at all. So NP dash which is equal to 0. அப்போ energy of the isotropic field which is equal to 0. So now I am going to calculate electronic configuration for high spin complex. High spin complex அப்படின்னா என்ன அர்த்தம்? அங்க வந்து பாத்தீங்கன்னா pairing does not take place easily. Pairing of electron does not take place easily. So the 5 electrons will evenly distributed among 3 orbitals in T2G orbital and 2 electrons in EG orbital. So the electronic configuration will be T2G power 3 and EG power 2. So crystal field stabilization energy for the above electronic configuration is formula என்னது? NT2G, number of electrons in T2G orbital 3 into minus 0.4 plus number of electrons in EG orbital 2 into 0.6 into delta O plus NP into P. NP என்னது number of electron pairs in Ligand field. Number of electron pairs in the Ligand field பாத்தீங்க அப்படின்னா நமக்கு எத்தனை electron pair இருக்கும்? Electron pairs எதுவுமே இருக்காது, எல்லாமே single electrons தான் இருக்கும் போது. So 0 into P minus of n dash P வந்து நம்ம ஏற்கனவே 0 ன்னு சொல்லிட்டோம். So இது all together simplify பண்ணும்போது we are getting the values 0. This is for high spin complex. The same thing I am going to do for low spin complex. Low spin means spinning, I mean the energy gap will be very very high. அதனால பாத்தீங்கன்னா the electrons will get paired up very easily. Electron will get paired up very easily. Previous topic la பார்த்த மாதிரி delta O will be greater than pairing energy. Pairing energy இங்க கம்மியா இருக்கும். So electrons ஈஸியா வந்து T2G ல pair ஆயிரும். So no electrons, no extra electron will go to the EG orbitals. சரியா? அப்ப the electronic configuration will be T2G power 5 and EG power 0. So upon substituting these values in the formula, I am getting the value as 32,000 per centimeter. Here 0, here plus 32,000 per centimeter கிடைக்குது. அப்ப high positive crystal field stabilization energy is found here, which shows high spin complex is favorable. Among low spin, high spin complex வந்து favorable. High spin நாலே அப்படின்னா என்ன அர்த்தம்? ஈஸியா வந்து என்ன செஞ்சிரும்? electrons வந்து pair ஆகாம higher energy orbital வந்து போகும். T2G ல இருந்து EG orbital வந்து போகும். Pairing does not take place very easily because in case of high spin, pairing energy will be very very high when compared to that of the delta O. Upper nature of the high spin complex is nature of the given complex is high spin, that is spin free. Electronic configuration for the central metal ion present here is T2G power 3 and EG power 2. Magnetic property, they have 5 unpaired electrons, so it is paramagnetic. Magnetic moment formula mu s is equal to root of n into n plus 2. Upon substituting the n value as 5, I will be getting the final answer as 5.916 Bohr magnetron. So this is the case for the first complex. The second example is FeCN6 3-. Here also the outer electronic configuration for ion is 3d6 4s2. If it is for Fe3+, it will become as 3d5 4s0. 3d5 means 5 electrons will be there in the isotropic field. No paired electrons are there, so np dash is equal to 0. Energy of the isotropic field is also 0. Here I am going to write the electronic configuration for high spin complex and low spin complex. High spin complex means no pairing of electron takes place, so T2G power 3 and the remaining electron goes to EG orbital, higher EG orbital, so EG power 2. Here low spin means pairing of electron takes place very easily, T2G power 5, EG power 0. So I am going to calculate crystal field stabilization energy for these two set of electronic configuration. So here for high spin complex I am getting the value as 0. For low spin complex I am getting the value as minus 10,000 per centimeter. Here I have got the value in negative term. Negative crystal field stabilization energy value indicates low spin complex is favored. Low spin அப்படினா என்ன அர்த்தம்? எலக்ட்ரான் வந்து higher energy க்கு வந்து shift ஆகாது. So the electron prefers to get paired in the T2G orbital itself. So the nature of the given complex is low spin, spin paired. Electronic configuration of central metal atom is T2G power 5, EG power 0. Magnetic property, here we have, it will be like this. 1, 2, 3, 4, 5. 5 electrons are there. சரியா? So கீழ வந்து T2G நமக்கு 3 orbitals இருக்கும். EG will be having 2 orbitals. So இது வந்து என்ன ஸ்பின் பார்த்திருக்கோம்? Low spin பார்த்திருக்கோம். So low spin means the electrons will not go to the higher energy orbital called EG. All the 5 electron will present in the T2G itself. So 1, 2, 3, 4, 5. Okay. So no more electron will enter into the EG orbital. So see here, 2 among the 5, 4 electrons are in the paired form and 1 electron is in the unpaired condition. So how many unpaired electrons are present here? Only 1. So that is what I have mentioned here. Magnetic property, number of unpaired electron is equal to 1. So though it has only 1 unpaired, it is paramagnetic. Magnetic moment formula mu is equal to root of n into n plus 2. So root of 1 into 1 plus 2, which is equal to 1.732. So the first complex shows high positive crystal field stabilization energy. So high spin complex is favored here. In second complex, negative crystal field stabilization energy shows low spin complex is favored here. So based on the crystal field stabilization energy, one can able to calculate, one can able to find whether the complex is high spin complex or low spin complex. Thank you.